A bicycle stands in the sun through a hot summer afternoon. By evening, its black tire and metal rim may be far hotter than the surrounding air. Sometimes the rider returns to find the inner tube flat, split, or even burst. The simple explanation is hot air expands, but the real mechanism needs one important distinction. A bicycle inner tube is not free to expand without limit. It is trapped inside the tire casing and rim. When the air inside becomes hotter, its molecules move faster and strike the tube walls more forcefully and more often. If the available volume changes only a little, the pressure rises. For a fixed amount of gas, pressure is roughly proportional to absolute temperature when volume is nearly fixed. Suppose the air in a tire rises from 20 degrees Celsius to 60 degrees Celsius. In Kelvin, that is a change from about 293 to 333. If the volume stayed constant, the absolute pressure would rise by roughly 14%. That increase alone does not normally destroy a sound, correctly inflated bicycle tire. But it can matter when the tire was already overinflated. The tube was pinched during installation. The rubber has aged. The rim tape is damaged or the casing has a weak spot. Direct sunlight creates another problem. Uneven heating. A dark tire absorbs solar radiation and a rim can become very hot, especially near braking surfaces. Rubber softens as it heats. Adhesives may weaken and the pressure pushes hardest against whatever part of the system is least able to resist it. A small defect that survives at a cooler temperature may fail after hours of heating. This is why the phrase, "the air expanded and burst the tire," is incomplete. The tube may expand slightly, but because it is confined, much of the thermal effect appears as higher pressure. Failure occurs when that pressure, combined with weakened material or excessive initial inflation, exceeds the local strength of the tube or tire. The same gas principle can be shown with a dented table tennis ball. Place it in hot water and the air inside warms. Its pressure rises and pushes outward. If the plastic has not been creased too badly, the dent may pop back into shape. The ball experiment works because the shell can deform. A bicycle tire, by contrast, is designed to hold a particular shape and pressure range. The practical lesson is not to guess by making a tire unusually soft every summer. Use the pressure range printed on the tire or recommended for the bicycle, measure pressure when the tire is cool, and inspect the tube, casing, rim tape, and valve. Never exceed the rated maximum. Leaving a bicycle in shade also reduces heating and slows rubber aging. Summer sunlight does not create pressure from nothing. It increases molecular motion. In a confined tire that raises pressure, while heat may simultaneously reduce the strength of already damaged materials. A burst is therefore usually the result of temperature starting pressure and a weak point acting together.